So this is module 5, Fourier transforms. So this module is module number 5, Fourier transform. So let us recall what is Fourier in Fourier series. So if f of x be a periodic function with the period 12 and satisfies, you remember that conditions, Dirichlet conditions. I'm not going to do that. Dirichlet conditions means it's periodic and only finite number of minima and maxima and finite number of discontinuities are there. Those conditions are called Dirichlet condition. Then f of x can be represented as Fourier. Okay,
Sir, screen share ಆಗ್ತಿಲ್ಲ.
okay. Then f of x can be represented as Fourier series. So you know that f of x is of the form a naught by 2 plus sigma n equal to 1 to infinity a n cos n pi x by L plus b n sin n pi x by L. So this is called Fourier series where a n, b n, a naught are constants. So here for a Fourier series, the function must be periodic. So that is a condition, that means function must be periodic. Now, if function is not periodic, can we represent it as a series form? The next our question is, for non-periodic function, can we represent a function in periodic? The answer is no. No, we cannot represent it as a series form. Rather, we can represent it as a integral form. Okay. So next is we define for non-periodic function instead of series we have integral. So if f of x is not periodic, okay, that is a condition, and defined in minus infinity infinity, that means defined all over the real line. Okay. And f of x is piecewise continuous. What do you mean by piecewise continuous? Piecewise continuous means I will draw a function. Suppose f of x is of this form. 1, 2, 3, 4, 5. So f of x is this function. Then this is piecewise continuous because it's continuous. It has only finite number of discontinuities. Okay. So such functions are called piecewise continuous function. And has derivative at every point. Then f of x has an integral representation. Instead of Fourier series, we have a Fourier integral. So now I will define what is Fourier integral. These are the conditions. If f of x is non-periodic and it is piecewise continuous everywhere and has derivative exists, then f of x can be written as a Fourier integral of the form f of x is equal to integral 0 to infinity a of omega cos omega x plus b of omega sin omega x d omega. So instead of in this summation, here it is integration. Instead of an, we have a function a of omega, and bn, we have a function b of omega, where 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 a of omega can be written as this is 1 by pi integral minus infinity to infinity f of v cos omega v dv. Similarly, we can find b of omega is equal to 1 by pi integral minus infinity to infinity f of v sin omega v dv. So this is called Fourier integral representation of a function. So instead of an, here a omega, b n, b omega. And remember one thing, for f of x, it is 0 to infinity, and for a of omega, we will consider minus infinity to infinity. So this is called Fourier integral. Okay. Now I define what is Fourier sine integral and cosine. This is very important. Next topic, Fourier cosine integral and Fourier sine integral. Fourier cosine integral and Fourier sine integral. Now, first one, Fourier, I will define what is Fourier cosine integral. Fourier cosine integral. So, if f of x as Fourier integral representation and f of x is even function, that is f of x is even function. We know that Fourier series, if f of x is even, we will get Fourier sine series, cosine series, and f of x is odd, we will get Fourier sine series. Okay, so similarly here, if f of x is even, then 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 we know that what will happen b of omega. By definition, what is b of omega? It's 1 by pi integral minus infinity to infinity f of v cos omega v dv. Tell me what will happen. What is even function? When we say that a function is even, anybody? Function f of x or f of v is even if f of minus v
F of
equal to
x equal to f of minus x.
f of okay, f of x minus x equal to f of x, or f of minus v equal to f of v. So here this is given E1, sorry, v of omega is sin omega v. Okay, sin omega v. Sorry, v of omega is sin omega v. What about the sin omega v? It's a even function or odd function? Sin function even ആണോ odd ആണോ? Odd or even?
Odd.
Odd function. So this is odd function. Now it's product of even and odd function. Product of even and odd function എന്താ? Is it odd or even?
Odd.
Odd. So total this f of v into sin omega is odd function. So what about what will happen? This integral minus infinity to infinity integral of an odd function is
Integral 0 to infinity.
odd ആകുമ്പോൾ
2 into integral 0 to infinity.
അത് odd ആകുമ്പോഴാണോ ഈവൺ ആകുമ്പോഴാണോ? 2 into വരിക
Odd 0.
odd ആകുമ്പോൾ 0 വരും. Okay. If it is even, then it is 2 into integral 0 to infinity f of v cos omega v. So if f of x is odd, then we know that integral minus a to a f of x dx is equal to 0. F of x is even, then we know that integral minus a to a f of x dx is equal to 2 into integral 0 to a of x. So here it is odd, therefore this is 0. Therefore, and also what will happen? A of omega. It's, by definition, it's 1 by pi integral minus pi to pi f of v cos omega v dv. Now f of v is even. What about cos omega? Is it even or odd? Cos function?
Even.
Even. So even into even?
Even.
Even function. So this will be even function, therefore integral becomes 2 times, right? 2 by pi integral 0 to infinity f of v cos omega v d. So this Fourier cosine integral is, so if f of x is even, then Fourier cosine integral is of the form Fourier cosine integral is of the form f of x is equal to integral 0 to infinity a of omega cos omega x d omega, where a of omega is equal to q by pi integral 0 to infinity f of v cos omega v dv. Okay, so this is Fourier cosine integral. So remember this formula. Now what will be Fourier sine integral? Fourier sine integral, if f of x is odd, then what will happen for v of omega? By definition, it is 1 by pi integral minus infinity to infinity f of v sin omega v dv. So f of v is given odd, right? Odd. Sin omega v, sin function is odd. What about their product? Odd into odd, odd ആണോ even ആണോ? Is it odd or it is even? Anybody? Odd function into odd function,
Even.
even. So this is even, therefore this become 2 by pi integral 0 to infinity f of v sin omega v t. Then what will happen? A of omega. By definition, it is 1 by pi integral minus infinity to infinity f of v cos omega v dv. And we know that this is odd and this is even. Odd into even, odd function into even function, is it even or odd?
Or
Odd, right? Odd. So this integral becomes 0. Therefore, Fourier sine integral is f of x is equal to integral 0 to infinity b of omega, because a of omega is 0, sine omega v, sorry, omega x d omega, where a of omega is equal to, sorry, where b of omega equal to 2 by pi integral 0 to infinity f of v sin omega v dv. So you have you got it? This is Fourier sine integral. So we have studied Fourier sine integral and Fourier cosine integral. Now we will do a problem. So write down a problem. One. Using Fourier cosine integral. Using Fourier cosine integral. So in the question itself, it is given that Fourier cosine integral. Show that integral 0 to infinity cos pi by 2 omega divided by 1 minus omega square cos x omega d omega is equal to pi by 2 cos x if mod x less than pi by 2, 0 if mod x greater than or equal to pi by 2. Okay. We have to show that by Fourier cosine integral, we have to show that this integral some, this is something like a of omega cos omega x d omega is equal to some f of x form. So now from the question, what is f of x? What is f of x here? Tell me. So this is cosine integral. Then what is f of x? Anybody? This part is f of x, right? That means f of x, we have to show that f of x is equal to integral 0 to infinity a of omega cos omega x dx or cos x omega d omega. So f of x is the right hand part, that is pi by 2 cos x if mod x less than pi by 2, 0 if mod x greater than. And we have to show that its a cosine integral is in that form. Now we have to find out Fourier cosine integral is of the form. So you write down first what is cosine integral. F of x is equal to integral 0 to infinity a of omega cos omega x d omega, where a of omega is equal to, by definition, 2 by pi, because it's a Fourier cosine integral. 2 by pi integral 0 to infinity f of v cos omega v d. Now you find out a of omega is equal to 2 by pi integral 0 to infinity f of v cos omega v d. Cos omega v dv. Cos omega v dv. So this is equal to 2 by pi integral 0 to infinity. Okay. So what is our f of v? F of x is given f of x is given this, and it is defined from mod x less than pi by 2, it is pi by 2 cos x. That means minus pi by 2 less than x less than pi by 2, it is pi by 2 cos x, and all other it is 0. So we can, our integral is from 0. So it is 0 to pi by 2. We have the value pi by 2 cos x and f of v. I am writing instead of x v, cos v, cos omega v dv plus pi by 2 to infinity, it will be 0 plus 0. Integral pi by 2 to infinity, value is 0. So this is 0. So that's why this is 0. So now we will integrate 2 by pi and pi by 2 get cancelled. Okay. So this is integral 0 to pi by 2 cos v cos omega v dv. Okay. So now we have to integrate this. Okay. So what is cos A cos B? So can you write cos A cos B? Anybody? In order to simplify integration, 2 cos A cos B. Is it cos A plus B? plus cos A minus B. Cos A plus B is cos A cos B minus sin A sin B plus cos A cos B plus sin A sin B. Sin A sin B will get cancelled. You will get 2 cos A cos B. So now we can simplify this integration 0 to pi by 2. Here instead of A, V, instead of B, so you can write it as 1 by 2 times cos V plus omega V plus cos V minus omega V dV, which is equal to 1 by 2 times 0 to infinity 0 to infinity uh, cos of, I can write, take V outside, 1 plus omega plus cos of 1 minus omega d omega d dv. So this is equal to 1 by 2 times cos of V plus 1 by V, which cos sine, integral is sine 1 by 1 plus V divided by 1 plus V plus V cos 1 minus omega V divided by 1 minus omega 0 to pi by, sorry, here it is pi by 2, right? Pi by 2. So which is equal to 1 by 2 times okay, cos, sorry, sine omega plus 1 or sine 1 plus omega pi by 2. Here it is also sine, right? 1 plus omega plus, then I am applying the limit, sine 1 minus omega pi by 2 divided by 1 minus omega minus, if I put 0 here, sine 0, 0 plus, here again, if I put V equal to 0, 0. So this is equal to 1 by 2 times. Okay, so I can write this as sine pi by 2 plus omega pi by 2. Sine pi by 2 plus omega pi by 2 divided by 1 plus omega plus sine pi by 2 minus omega pi by 2 divided by 1 minus omega. Now, what is 1 by 2 times? What is sine pi by 2 plus theta? So you can write sine pi by 2 plus theta is sine pi by 2 cos theta plus cos pi by 2 sin theta. Cos pi by 2 is 0. So sin pi by 2 1. Therefore, this is cos theta, right? Sin pi by 2 plus theta is cos theta. Therefore, here you can write cos, instead of theta, here it is cos omega pi by 2 divided by 1 plus omega plus What is sine pi by 2 minus sine pi by 2 minus theta? That is sine pi by 2 cos theta minus cos pi by 2 sin theta. This is 0. This is again cos omega pi by 2 divided by 1 minus. So this is equal to, I can take cos omega pi by 2 outside, cos 1 by 2 times cos omega pi by 2 do 1 by 1 plus omega plus 1 by 1 minus omega. So this is cos omega pi by 2 divided by 2. So I can cross multiply, therefore 1 minus omega plus 1 plus omega divided by 1 minus omega square. This and this get cancelled. 1 plus 1 2, right? 2 and 2 get cancelled. So what is this? This is cos omega pi by 2 divided by 1 minus omega square. So I got a of omega is equal to cos pi by 2 omega divided by 1 minus omega square. Thus Fourier cosine integral is f of x is equal to, that means f of x is pi by 2 cos x if mod x less than pi by 2 and 0 if mod x greater than pi by 2 is equal to integral 0 to infinity a of omega is cos pi by 2 omega divided by 1 minus pi omega square cos omega x d omega. So this is, we have to hence so this what we have to show. That is the question. From the question we have to show this, right? So we, by using Fourier integral, we find that this integral. Now I will give a question for homework. Find Fourier integral, Fourier sine integral using, please note down, using Fourier sine integral. Show that integral 0 to infinity 1 minus cos pi omega divided by omega sin omega x d omega is equal to pi by 2 if 0 less than x less than pi, 0 if x greater than pi. So this is